Here's the console of the 3750 switch. Show MAC address table. Some MAC addresses are listed in the table. What I'll do now is ping from router 1 to router 2. Show IP interface brief. Router 1 has this IP address, and router 2 has this IP address, which we can see on the console of router 2. So there's the IP address of router 2. Router 1 is once again able to ping router 2. So when we look at the MAC address table of switch 1, previously we only had those 3 MAC addresses in the table, but now notice we have this MAC address as well as this MAC address in the table. I have configured the MAC address of router 1 as follows. So I'm using a Cisco vendor code MAC address, and to make it simple, I've specified the MAC address of router 1 as follows. On router 2, I've done something similar. So MAC address is the Cisco vendor code, 0s and a 2. So at this point, the first 3750 switch has learnt about the MAC addresses of router 1 and router 2. To keep things simple, I haven't configured any VLANs. All devices are in VLAN 1. Let's capture traffic in Wireshark on our PC. So it's currently receiving some traffic, but let's do a ping from router 1 to router 2 once again, and I'll filter for ICMP traffic. In the output here, you can see that the PC is not receiving any ICMP traffic from router 1 to router 2. And in the same way, if router 2 pings router 1, no ICMP traffic is shown on the capturing PC. But if router 1 pings this Windows PC, which has an IP address of 10.1.1.222, notice we see the ICMP packets. So Wireshark is able to capture traffic from 10.1.1.1 going to 10.1.1.222. So the PC is not able to capture unicast traffic sent from router 1 to router 2. What about multicast traffic? In this example, you can see that the ICMP traffic was received to the multicast address. So router 1 with IP address 10.1.1.1 is sending traffic to the multicast address 239.1.1.1. You can see as an example that the source MAC address is router 1, destination MAC address is 01005E, which is the multicast MAC address in IP version 4, as you can see over there. What about a broadcast? So I'll ping 10.1.1.255, and I'll just repeat this once. As you can see here, broadcast traffic is being received by the PC. So in other words, unicast traffic sent from router 1 to the capturing device is forwarded out of this port, and that's based on the MAC address shown here as learnt by the 3750 switch. On this PC, I have changed the MAC address in Windows to a bunch of zeros and a 1. So the MAC address is 11 zeros followed by a 1, and that was learnt by the switch on Fast Ethernet 105 as shown over here. So unicast traffic gets forwarded to the PC, multicast traffic gets forwarded to the PC, and that's because multicast MAC addresses are not added to the MAC address table in the same way that unicast MAC addresses are, broadcast traffic is also forwarded to the PC. So to summarize, I'll restart the Wireshark capture. Unicast traffic sent from router 1 to router 2 is not received by the capturing device. Multicast traffic is received. Broadcast traffic is received. If we want to capture traffic from router 1 to router 2, for troubleshooting as an example, we would need to enable span on this port, or mirroring to use the other term, so that traffic sent and received on this port, or on VLAN 1 in this example, is forwarded out of this port so that the capturing device can see the traffic. As another example, if we telnet from router 1 to router 2 and log in, the capturing device does not see the telnet traffic. So we can't see the session from router 1 to router 2, and that's because the switch is doing what it's supposed to do. It's forwarding traffic from this interface to this interface and not sending it out of unnecessary ports. So now let's configure span so that the capturing device can see the unicast traffic.